Hello students, hope you're doing good. In the earlier class we have discussed the basics of motion. In this session we're going to discuss about the concept of distance displacement. So basically 5 terms are very important for kinematics and dynamics, okay, of IIT-JEE: distance, displacement, speed, velocity and acceleration. So these 5 terms should be very strong conceptually. So if you understand these 5 terms clearly, the kinematics and dynamics concept, not only the kinematics and dynamics of IIT-JEE, the other concepts also, they will become simpler whenever you're dealing with motion, okay, motion or motion of the objects. Now, what we'll do is, so before starting of this distance and displacement concepts, we'll just have a small recap of the earlier session, what we have learned. That is simple basics of motion. Now, as I discussed that motion is nothing but change in position of an object with respect to time and a chosen reference frame. So, if the object is changing the position, okay, if the object is changing its position from one place to other place, then, and how it is changing with respect to time, this is very important. I told you this is a reference. So, if the object is changing places with respect to time and a chosen reference frame, this is very important, a chosen reference frame. For example, this entire earth can be taken as a reference frame, okay, if you want to study anything. So the earth is one frame of reference. For example, objects are moving in some bus or some truck or some trolley. So the trolley itself can act as a frame of reference. So whatever the object you want to study, first you have to define the frame of reference. This is very important. And of course, the time is a very important reference because every activity will be measuring with respect to time. So time we cannot omit, and reference frame is very important because as the reference frame changes, things will also change. For one object or for the one person, the object may be at rest. For the other person, the same object may be in motion. So that's why I told you that the motion is not absolute. Okay, remember this thing. So motion is never an absolute. So motion and rest. So these are basically relative terms. They're not absolute terms, they're relative terms. So is motion absolute? No. Motion is never absolute. For one person, the object may be at rest. For the other person, the object may be at in maybe motion. So, and one more thing is, the motion actually depends on the observer. Okay, just now I was telling this point. Motion depends on the observer and it depends on the frame of reference. So this also example I have discussed earlier. So I'll just let's have a small recall of this. So there are two persons going in the bus. Okay, this is a person 1. This is a person 1 and this is a person 2 and there's one more person 3 who is standing, okay, on the road looking at the bus, okay, looking at the two persons going in the bus, and the bus is moving. This is the first thing. So the bus is in motion. When I say bus is in the motion, it is with respect to the ground, with respect to this ground. Remember this thing. So everything, and it is moving. Okay, so bus is changing positions with respect to time and with respect to a chosen reference frame. So the reference frame here is earth. So it should be very clear, whenever an object is moving, these two things you have to mention. One is the time, the other is in which frame of reference the object is present. So now, this bus is moving. Okay, now let us understand this concept of motion and rest, okay, which earlier I have dealt with. So the object is moving, okay, the bus is moving. So the person 1 and person 2, okay, let us say they are two friends. So the friend 1, and remember, this is the object of study. So the person 2 is object. Okay, or body you can call, and the person 1 and person 3, they are the observers. They are observing the object. So both are these two persons, they are sitting side by side. The person 1 is looking at the object. Now, so the person 1 is observing that the person is sitting. Okay, he is at rest. So for this person, the object 2 is at rest. But for this person who is standing outside, okay, this person will be in motion. So clearly you can just see it depends on the observer. So for the first observer, the object is at rest. For the third observer, okay, for this observer, the same object is in motion. Why? Because the reference frame is different. So for this person, okay, for the first person, the reference frame is the bus. Okay, for this guy, the reference frame, okay, simply in short I'm calling as RF. RF for reference frame. So for this guy, The reference frame is the bus itself, okay, on which he is sitting, or the entire chairs, all the persons, okay, all the things which are on the bus, okay, the framework, that itself is nothing but reference frame. Now, for this person who is standing on the road itself, there is a earth itself is nothing but is the reference frame. So, for the first person, the reference frame is different. That is why the object is in rest. For the second person who is standing outside the bus, the reference frame is earth. That is why the person is moving. So that's why the reference frame is very, very important. This is why I told you. So whenever we are talking about objects in motion, we should first define which frame of reference the object is present. Now, hope this is clear. So remember, rest and motion, they are not absolute. They are always relative. For one person, it can be at rest. For the other person, it can be in motion. Okay, hope this is clear. Now, this concept just now I have explained. Now just here, so imagine that you are sitting in moving bus. Now relative to the bus, with respect to the bus, relative, or you can call with respect to the bus. Okay, all the objects. Okay, if all the persons are sitting, then all are at rest. Very simple. Now with respect to, or you can call relative to the road. With respect to the road, the entire bus is moving. So the bus is in motion. Okay, or all the objects present inside the bus, all the persons, they are moving. Okay, this clear. Now, this also I explained. If I am standing still in front of this digital board, am I in motion or rest? Now, this also I explained. So it depends on the observer, from where you are observing. Okay, for example, all the objects, all the living and non-living things on the earth, they are actually moving. For whom they are moving? For the person who is entirely away from the earth. For example, there is some person, okay, totally away from the earth, okay, almost near to the sun. Let us say nothing is happening to this guy, and he's watching this entire the objects on the earth. So the entire earth is moving. Okay, this is very clear. So all the objects are in motion for this guy. And earlier I told that, so this earth, okay, the motion is 30 kilometers, approximately 30 kilometers per second. That means every object, even now, okay, even now, if I'm standing here, I'm moving at a speed of 30 kilometers per second. Okay, for this guy who is standing outside, okay, away from the earth and watching me. Hope this is clear. So that means I'm moving at a speed of 30 kilometers per second. Now the interesting question here in the physics is, now am I feeling that the earth is moving? If you're going on a bike sitting, you will feel that you are moving. But here, all the objects are on the earth, they don't feel as if the earth is moving. Why? Okay, this concept we'll discuss later. Okay, just I'll discuss this concept earlier. Now let us understand just what is motion and rest. Okay, simple basics right now. Hope this is clear. So it depends on the observer whether the object is at rest or motion. Now, for the objects present on the earth, okay, if the other objects are not moving, then they are at rest. So it depends on the observer. Okay, hope this is clear. Now, let's come back to our concept of distance and displacement. Now, first, let us discuss this distance, and afterwards, let us move to the concept of, okay, displacement. So, what is distance? Now, distance and displacement. In physics, you will get so many quantities. What is this quantity? Any quantity which is varying, or quantity means anything which is variable or measurable. In the physics, you will get so many quantities. Okay, distance, displacement, you will get acceleration, velocity, you will get a current, okay, magnetic flux, electric flux. All these quantities, basically they are called physical quantities. So physical quantities are nothing but quantities where we can measure. Okay, so if you understand this physical quantities properly in physics, you can quantify anything. Now, our physical quantity. So basically, this distance is nothing but a physical quantity which will measure the length. Now, so what is distance? So distance is nothing but it is the actual path length traveled by an object. An object is continuously in motion. So now, to what distance or to what length the object has moved, that this distance will tell. Or in simple to say, distance is nothing but it is a total path length traveled by an object. Okay, you can just hear. So distance is nothing but actual path traveled by the object. So to explain this, so you can just see, okay, there is a small path here. Now, let us say this is my home. Okay, and say this point is say my school. You just, okay, assumption. Now, at this point A, now, so this point, this I'm calling as point A, this I'll call point B. Now, I'm standing at point A. Point A is where I will start my journey. So, this point where I will start my journey from home is called as generally initial point. So, in this physics, the terminology is very important. So, you should be very comfortable with this physics terminology. Initial point, or you can call initial position, or it is called as a source. Source point, or simply you can call source. Now, coming to the point B, where exactly I will go? That point, the final point. So, this is called as final point. This is called final point, or you can call final position, or you can call it as a destination. You can call this as destination. Now, from source, I'll be moving to destination. So, I need to have some route. So, let us say I'm taking some route to reach this point B. So, what I'm doing is there are two paths. So, this is one path, you can just see here. This blue color path, this is one path, and there's one more path. There is one more path. Okay, the straight line path. Two paths are there. So, I'll just name this. This is a path 1, this is a path. So, I'll start from A and I'll start moving to B. So, now as I'm moving continuously, just here, I'm starting from my home, continuously moving, step by step I'll move. Every step as I move, I'm covering certain length. So, continuously I'm covering certain length and I'm continuously moving along the route, and finally I'll reach the destination. So, from source to destination, I'm continuously moving step by step. Now, I'll count every step with the help of a meter scale. So, I'll measure the entire steps and I will count that entire length is nothing but the distance. Hope this is clear. So, in simple to say, distance is nothing but how much ground the object has been covered. Okay, so how much ground an object is covered. Understand this concept very clearly. Okay, the clear difference between distance and displacement. Now, so what is the meaning of how much ground an object is covered? Every step the object is moving ahead, it is counted. Okay, you can measure with certain meters. So, for example, okay, what I'll do is to explain this properly. Okay, I'll just elaborate this concept of distance with an example. Let us say this is point A, which is the source or the initial point, and there is some point B here. This is nothing but the destination. So, source and destination are present at far distances, okay, or far. Now, from source, I want to move to destination. Okay, this is my home, that is my school. So, there are different routes. Let us assume that there are different routes. This is one route. Okay, this is one more route, and there is one straight line route. There is one straight line route. Okay, from A to B. This is one straight line path. Now, apart from this is a route 1 I'll call, this is a route 2, I'm just naming all the routes. This is a route 3, from A to B, there is one more route. This is route number 4, and this is route number 5, and the one more route, okay, something like this. The route number 6, there are different routes like this. Now, A to B, I want to move. I have different choices. I can move in any route. Now, what I'll do is, now I'll choose the first route. Let us say the first route I'll choose. This is the route I'll choose. Okay, I'll start from here, the source. I kept on moving. Okay, I'll reach my destination. So, let us say that particular length, whatever I have covered, okay, the distance, okay, the length, whatever I have covered, every step I'll count and I will move to B from A. So the distance, whatever I have covered, let us say I'm just, for example, I have covered say 1 kilometer. Let us, example I'm taking 1 kilometer. That you can write like this: AB equal to 1 kilometers. Now I'll do is I'll take path 2. Okay, let us say I'm starting from A and I'm going to B, taking via path 2. So AB, so this is path 1. So AB path 2. So path 2, let us say it is say 1.2 kilometers. So this 1.2 kilometers, what I'm calling, that I'll call distance if I take this path 2. Now this 1, if I take path 1 and if I reach B, that I'll call distance. What is the distance means? I can call 1 kilometers. Now taking path 2, what is the distance means? I'll call 1.2 kilometers. So I'm using the word distance. Distance is nothing but how much the object is covering the entire path. That length is nothing but distance. Now similarly, the path 3, okay, path 3, it is shortest path. You can just see it because straight line path it is. So this is a path 3. This, okay, let us say it is say 0.5 kilometers. Okay, roughly I'm taking some values to make you understand the concept. Now from A to B you take path 4. Okay, some distances. So path 4 is say 1.5 kilometers. Okay, path 5 is say some, okay, 1.9 kilometers, and path 6 is the longest path. You can just see this. So the longest path, let us say this some 3 kilometers, 3 or 4 kilometers, whatever. Now out of all these paths, so wherever the object is covering the paths and measuring the entire length step by step, that is nothing but the distance. So distance along the path 1 is nothing but 1 kilometer. The distance along the path 2 is nothing but 1.2 kilometers. So remember, I'm measuring everything in terms of kilometers. So the units of distances are nothing but they are, okay, the unit of distances is nothing but it is, you can measure in kilometers. Okay, the units you can measure in kilometers or meters. The units can be kilometers. You can measure in meters or you can measure in centimeters, etc. Whatever. Okay, the units of length. So basically, distance has a units of length. So units are kilometers, meters, centimeters, whatever. So if the distance are larger, we'll use a bigger unit called as kilometers. If the distance are smaller, you can use centimeters or meters or millimeters, whatever. But SI unit, if you say, what is the SI unit of distance? That is nothing but, okay, meter. So meter is the SI unit. Hope this is clear. CJS unit is centimeter. Fine. Now, coming back to our discussion. Now from A to B, the object is moving and it is covering different paths. Now, what out of all these paths, what is the shortest path it is covering object, or which is the best path, okay, which I can go from my home to school. Okay, the source is a home I'm calling, this I'm calling as school, destination is a school. The shortest path is nothing but path 3. This is the best path. I'll take less time to go. Now, this path 3, which is the shortest distance between point A and point B, that is source and destination, is called as a displacement. So now I'm just shifting the concept to displacement. So displacement is nothing but it is the shortest distance between the source and destination. If it is not shortest between those points, then it is never a displacement, it will be simply a distance. And one, okay, main important difference between distance and displacement is distance is a scalar and displacement is a vector. This is a very, very important. Yeah. Distance is a scalar and displacement is a vector. Now look at this. So I'll just write here. So remember, distance is a simple scalar. What is this scalar and vector? Now, in simple to understand this scalar and vector, scalar is nothing but any physical quantity. Okay, any physical quantity like distance, time, or current. So there are some physical quantities in physics which don't have any direction. Time has no direction. Okay, mass has no direction. Distance has no direction. So those quantities which have no direction, they have only a value. Okay, a value and a unit. They are called scalars. Okay, I'll tell simple example. Okay, I'll tell, because this concept of scalars and vectors is very important for physics. So scalars, okay. So just understand the simple concept of scalars and vectors. It's very important. Throughout the physics, we'll be using this concept called, okay, this scalars and vectors. In simple terms, I'll explain. Okay, detail, okay, I'll take some other video. But for now, timing, understand what is scalar. Scalar is nothing but any physical quantity which has only magnitude. Any physical quantity which has only magnitude. Any quantity which has only magnitude is called as scalar. Okay, the examples of scalar quantities are, okay, just now we have seen there is a distance, or it can be time. Time is a scalar. Time has no direction. Okay, and mass and current. Okay, density. All these things. Okay, there are so many physical quantities which have no direction. Time has no direction. Mass has no direction. Distance has no direction. Current has no direction. Density has no direction. So all these quantities are called as scalar quantities in physics. Now coming to the vectors. Now, whenever you are handling a vector, remember this point, very, very important point. Whenever you are handling a vector, immediately the first question you have to ask is, in which direction the vector is moving, or in which direction the physical quantity is moving, or what is the direction of that vector you have to ask. So this is the first point. Whenever you're handling the vectors, you have to ask this question, in which direction the object is moving, or in which direction the quantity is moving. Now, so basically vectors are nothing but, okay, those physical quantities which have, okay, quantities which have both magnitude and direction. If the object, or if the quantity is having only magnitude, if the object is having only magnitude, if it is having only magnitude, it is scalar. When I'm saying magnitude, obviously see here, whatever scalar or vectors, they'll be having a units. Without units, we can't describe anything in physics. So scalar has some magnitude and some units. For example, distance, okay, some 10 meters. Now time, some 20 seconds. Okay, mass, okay, some examples I'm just numerically I'm just writing. Mass is say some 10 kg. Okay, current some 2 amperes. Density, okay, say some 6.8 grams per centimeter cube, something like this. So for everything there'll be unit, whether it is scalar or vectors. They'll be having, now scalars will be having units, and they'll be having some values, magnitude we call, and they don't have direction. Now coming to vectors, vectors they have both magnitude as well as direction. So when I'm calling direction, what is this concept of direction? This is also very, very important. People don't know. Okay, so since we are dealing with JEE Foundation, you should know exactly what is this direction. So this also I'll just explain a little bit, because whenever you are dealing with mathematics and physics, you should know what is exactly direction in physics. Okay, or in this mathematics. Now, direction. So direction in physics or mathematics means, earlier I told that from A to B I am moving. From source to destination, object is moving. If the object is moving from source to destination, now the question is, in which direction the object is moving, I'll ask. Now, earlier I told that the shortest path between A to B is nothing but the straight line distance. Okay, this you know from basics of mathematics. Yes, shortest distance is nothing but a straight line distance. Now, this shortest distance, if you just see carefully, it is starting from A, it is moving to B. Now, if I stand on this line, and if I start moving, am I moving in a single direction? I can call. I am moving in a single direction. I am moving in a single direction. Remember these things. only along the AB, x-axis I can call. Now, if I want to move to B, but I have a different route. Now, A to B I am moving. So this is the first route. In the first route, I am moving in particular direction. There is a rightward direction I can call. Okay, some eastward direction. So that east is nothing but direction. Now, from A to B, I am moving. Now, is there one particular direction? No, there is no particular direction here. If you just see, this is a concept of, I'll start from A. So let us say this is a path 2. I'll start from A, I'm going to B. See here, I'm going downwards. I'm not going eastwards, I'm going downwards. Okay, slightly I have moved leftwards. Again, I'm going downwards. Okay, again, slightly I'm going rightwards, eastwards. Okay, again, I'm moving upwards. Okay, there is some northeastwards. Now, again, I'm moving a little bit right. Okay, now again, I'm moving downwards. Okay, southeast, something like this. So, there is no particular direction we say here. Okay, in the physics, we say there is no direction. I'm just moving in different paths. Okay, I'm going downwards, leftwards, again rightwards, upwards, downwards. So there is no particular direction in this path if I start moving from A to B. So this A to B path, which I will cover, that is I'll call simply distance. And this path from A to B, the shortest path, that I'll call displacement. So this path is a displacement path. So in short, you can write as this AB bar. So generally remember, since a displacement is a vector, it will be having a direction, it will be having a magnitude. For example, A to B, let us say it is 1 kilometer. 1 kilometer. Now, vectors are denoted by, so from A to B I am moving, the denotation is like this. A to B, so they will show with an arrow. That arrow indicates that it is a vector quantity. So I'm talking about a vectors here. So what vector is it? Is a displacement vector. So this AB bar is called as a displacement. So that AB bar is a displacement. Now, from A to B I am moving. This is not a vector. So I'll cover the distance from A to B. Okay, I'll not call this as a displacement. I'll call simply distance only. So this AB, I'll not put any arrow, anything. I'll just leave it like that. So AB is nothing but the path length. Let us say some 6 kilometers. Roughly, I'm taking 6 kilometers. Let us assume some value. So this AB, if I don't put any arrow, these are notations. So whenever there is an arrow on the variables or the letters, then that will denote a vector quantity. If I don't put anything, there is simply a scalar, and this scalar quantity is nothing but distance. Okay, which is our topic. Now, hope this is clear. Now, when I say displacement, it is a vector. So, in which direction the object is moving? It is moving eastwards or rightwards. So, direction is here eastward. There is a direction. Eastwards, or you can call rightwards. Hope this is clear. So, this direction concept is very, very important. Okay, that is what I want to make you understand. Now, coming to distance. This AB equal to 6 kilometers. Distance is 6 kilometers here. Now, I'll ask what is the direction for this distance? There is no direction. Why? Because it is coming down. Okay, it is going left, again moving right. Okay, again moving up. There is no particular direction, I'll call. So, distance has no direction. It is having multiple, okay, directions. That is not called direction in physics. So this very direction means in one particular straight line path the object should move. That's it. Very simple. Now, how to understand this direction? Okay, for vectors, for not only for displacement, for any vectors, we have to understand this direction. How to measure this direction? So direction you can measure, okay, with help of angles. So with help of angles you can measure the direction, and with help of slopes you can measure the direction. With help of direction cosines you can measure the direction. So there are different ways to measure the direction. Remember this thing. Okay, this also is very important. I'll just add this point. Now, since I have touched the topic of vectors, I'll just make these points clear. They'll be useful for your mathematics, not only for physics. Now, direction. So direction can be measured, okay, direction can be measured direction can be measured help of the first thing is with angles. We can measure the direction. How you will measure the direction? With the help of angles. This is one way of measuring the direction of vectors, angles. For example, just now I told you, okay, the object is moving from left to right. In the earlier example, the object is moving from A to B rightwards. Okay, if it is moving rightwards, it will be having some angle. The angle is at 0 degrees. That is an angle. Okay, that 0 degrees is nothing but direction. Now, if I say 90 degrees, the object will be moving like this from bottom to top. Okay, this is 90 degrees. So the object is starting here, it is moving upwards. Hope this is clear. Now, so the angles will give the directions. And for example, the rocket is moving, okay, from space station, okay, or the ground, from the earth, the rocket is moving. So in which direction the rocket is moving? The direction is very important. They'll measure practically with the help of angles. Hope this is clear. So not only this, with the help of slopes, we can measure the direction, because slope is directly proportional to the angles. So in mathematics, what they'll do is to measure the direction of any line, they'll put simply m equal to tan theta. So m is the slope, theta is nothing but angle. So direction you can measure with the help of angle or with the help of slope, because both are directly proportional. Now, not only this, in mathematics, okay, when an object is moving or a line is there in a space, then those lines, directions you can measure with the help of direction cosines. This you will study in your 11th concepts, 11th and 12th concepts. Direction cosines we call. So whatever, just remember these concepts, very, very important. How you will measure the direction? Angles or slopes or direction cosines. For time being, just remember angles. Enough. Okay, for 9th and 10th standard, IIT-JEE Foundation. Now, let's go back to our topic of distance and displacement. Now, hope this is clear. What is distance and what is displacement? Displacement is nothing but it is a distance plus direction. Remember this point. Distance is nothing but it has no direction. It is simply a scalar quantity. Now, let us see certain points, or let us recapitulate this. Now, first point about the distance. This also told you earlier. How much ground an object covers? That is nothing but distance. How much ground it is covering? I'll tell a simple point regarding this. The object is starting at point A. It is going to point B. Okay, from A to B, distance is say some 100 meters. Object is starting here. It is going to B. It is not stopping at B. Again, it is taking the same path and it is stopping at same point A. So the initial point and final points are same. The initial point and final point are A itself. They are not B. B is just some intermediate point. The object is starting from A, going to B, again coming to A. So the initial and final points are same. If the initial and final points are same, even then the distance will not be 0. Why? Because distance will be always positive. Remember this. Distance can't be negative. Worst case will be 0. Now, the object is going from A to B, 100 meters is covered, and again it is coming back, 100 meters covered. So total distance is nothing but, so our total path traveled is nothing but 100 plus 100, that is 200 meters the object has covered. That is nothing but distance. So this I am calling as a distance. Hope you are getting my point. But remember, the interesting thing is initial final points are same. The object has covered some distance. So whatever it is, how much ground it is covering, okay, wherever it is going, every step you have to count. There is nothing but counting the how much ground an object has covered. Okay, hope this is clear about the distance. Now, but for the same example, if I ask what is the displacement, the displacement is nothing but simply 0. Why? For the same example, displacement. Okay, displacement for the same example is nothing but simply 0. Why it is 0? Why? Because displacement depends only on the initial and final position. Remember this point. Displacement depends only on initial and final point. It doesn't depend on anything else. Okay, in the earlier example, you can just see this. The object is moving from A to B, taking a straight line path. Okay, the shortest path. That I am calling as displacement. Now, so displacement depends only on initial and final positions. Very, very important point you have to keep in mind. If the initial and final points are same, the distance will be same. Displacement will be 0. Remember this point. So displacement depends. Okay, very important point. Depends only on initial and final points. Okay, not on anything else. That's it. If you know initial point, final point, that's it. Draw a straight line, that is nothing but, and measure the distance and take the direction, that is called as displacement. Finish. Hope this is clear. For example, this point B is somewhere here. That's it. Okay. This is a displacement and the direction is somewhat tilted. Now, if the point B is here, okay, so this is a displacement. Now, if A and B are coincident, then displacement will be 0. Hope you are getting my point. So the initial and final points are important for displacement. Now coming back to our distance. Okay, distance. Now if you just see this, first thing is I have discussed that distance is scalar quantity. Now when I am calling scalar, it has only magnitude and certain unit. What are the units of distance? Just now I told you. It can be meters, kilometers, okay, whatever, the units of length. And remember, and next point is distance is always positive. Distance can never be negative. Remember these things. Distance can't be negative. Distance can't be negative. In case distance comes out as negative, that means somewhere you have gone wrong in the problem, or your concept understanding itself is weak, or you don't understand the concept of distance. So distance is always positive, because every step if you put ahead, obviously that distance is counted wherever you go. So distance is always positive, don't forget this. So distance can't be negative. The worst case distance will be 0. So this, what I can write is, if d is the distance, distance will be always greater than 0. Mathematically you can write down like this in simple one equation. So d is greater than or equal to 0, and a unit of distance is meter. Okay, if the unit is larger, you can go for kilometers and so on. Okay, hope this is clear. Now distance can't be negative, so that point you have to keep in mind. Now coming to concept of displacement. Okay, earlier I have discussed. So distance, okay, displacement in short you can write down like this. So displacement is nothing but it is distance plus direction. Distance plus a direction. Remember these things. Now when I'm calling a direction, it is an object moving in a straight line path only. That's it. Okay, this direction I'll just, okay, I'll explain a little so that it will be clear. So now remember, displacement is nothing but it is a distance covered by the object plus moving in a straight line path or in one particular direction. Now see here. Okay, if the object is moving like this, object has a direction. Now, if the object is moving like this, object has a direction because straight line paths. If the object is moving like this, is a direction. Okay, object has a direction. All these are vector quantities I can call. Now, if the object is moving like this, it has no direction. In physics, we don't call this as a direction. Remember this point. If the object is moving like this, no direction. Okay, if the object is moving like this, no direction. So direction in physics means object has to move in the straight line path. And how we will measure? With the help of angles, or with the help of slopes, or with the help of direction cosines. So this concept of direction is very, very important. Okay, so don't forget this. Now coming to our points of displacement. Displacement is a vector quantity. When I'm calling vector, vectors can be positive, vectors can be negative, vectors can be 0 also. Now let us look at this. Okay, so remember, first thing is displacement is always a vector quantity. Okay, which is clear. Now second point, displacement can be positive, negative or 0. Now why? So displacement, what I'll do is I'll call it capital D. So capital D is equal to, it can be positive, capital D for displacement. Displacement can be positive, or displacement can be negative, less than 0, or displacement can be equal to 0. So let us understand this. When displacement will be positive, when it will be negative, when it will be 0. Okay, the same example. Okay, the same story. Object is moving from A to B, and remember, it is moving the shortest path. The shortest path is nothing but R displacement. Okay, from A to B, if I measure the distance and take the direction, then it is displacement. Now, object is starting from A to B. Now what I'll do is, okay, say this A is origin. Okay, origin I'll call 0, and here from O, from this origin O or the point A, it has moved to B. So till B, say it is some 10 meters. The object has started at A and it has moved to B, some 10 meters it has covered, straight line path. So this, what I'll do is, in notation, they will write like this. AB bar, okay, don't forget to keep the arrow. If I keep the arrow, there's a displacement. So AB bar is equal to 10 meters. So this is a displacement. Now, the same object, okay, or the same object, okay, this person has moved right, AB bar equal to 10 meters. The same person is moving left. The same guy is moving left in the straight line path, and he is moving the same distance, 10 meters. Okay, exactly at here, it is 10 meters, let us say. Now remember, from A to B, it is displacement, shortest path. From A to C, that is also displacement. But he is starting from 0 meters. Okay, here this way, 0 meters. Now, this path, this AC bar, this I don't call 10 meters. If I call 10 meters, there is no difference between this as well as this. So I'll call AC bar as minus 10 meters. Now the question is, why minus came? If the object is moving towards the right, I am taking plus 10 meters. If the objective is moving left, I'll take minus 10. So this clear. So plus and minus signs for vectors, they are coming because of directions. Hope this is clear. So this is one vector. Okay, AB bar is one vector. AC bar is one vector. Both are displacements only. Okay, one is measured along the rightward direction, taken as positive. The other is measured along leftward direction. Since it is moving leftwards, I'm taking as negative direction. That's it. So plus and minus signs. So both are vectors only, both are displacements. So plus and minus sign. Now, for example, the object is staying at A, it is not moving. Then it is taken as null vector. Okay, or what I'll do is, for example, this is the initial point A. The object has moved to, okay, instead of A, I'll take some other point. The object is starting from C, it is moving to a certain point D, and again it is coming back to C. So the initial and final points are C itself. This is the initial point as well as final point. So if the initial and final points are same, then displacement will be 0. Okay, so here, for this case, the displacement is simply 0. Why? Because displacement depends only on initial and final position, that's it. So displacement is 0. So when displacement is 0, what happens is, now as I told that displacement is a vector. Now what is the direction for this vector? This vector whose value is 0. So whenever the vector is 0, we call it as a null vector, and this is a displacement vector. Displacement null vector this is. So what is the direction of null vector? Direction of null vector is indeterminate. Okay, remember, it has no particular direction, so we call indeterminate. Hope this is clear, right? So null vectors have no direction. Okay, null vector direction is indeterminate. Null vector has indeterminate direction. Now what is this indeterminate? You cannot determine the direction. That is the meaning of it. Indeterminate. You will be unable to find out the direction. That's the meaning of it. Now, so this clear. So displacement can be 0, displacement can be positive, displacement can be negative. So why plus minus signs are coming? Because of direction. If the rocket is moving above, okay, if the rocket is moving, okay, vertically upwards with some, say, 10 kilometers per second, okay, roughly, some example I'm taking, some value. This is a velocity. And for example, the same rocket, after going to certain distance, it is coming downwards. I can measure this as minus 10 kilometers per second downwards. That minus is showing the direction, that's it. So plus and minus signs in the vectors, they will give the directions of the object, nothing else. Now let's go back to our concept of displacement. Now, so remember, displacement can be positive, negative, or zero. Now coming to units of displacement. Displacement unit is same as units of distance, so it will be in meter. SI units will be meter. You can, if you want, you can measure in kilometers, okay, and other units, millimeters and so on. Now let us see some basic questions related to this concept of distance and displacement. Now, when distance and displacement are equal, when distance and displacement are equal, this is the first question. Now, distance and displacement will be equal if and only if the object is moving in the straight line path. Okay, so remember, the straight line path, if the object is moving in straight line path, then distance will be equal to displacement. That is the answer. So answer for this is distance. Okay, distance I will be calling with small d, and capital I will be denoting with distance small d, and displacement with capital D. So distance will be equal to displacement, okay, if object is in straight line path. If object moves in straight line path, okay, this ST stands for straight line. If the object is not moving in straight line, there is no question that distance will be equal to displacement. Very, very important. And one more important point I want to cover is, remember, distance will be always greater than or equal to displacement. See, displacement can be positive, negative, or zero, whatever. Okay, so if you take the absolute value, absolute means I'm taking always positive value. So if that positive value of displacement, if I compare with the distance, distance will be always greater than or equal to displacement. Remember this point. Why? Because distance is always positive, okay, and displacement can be negative. And displacement is shortest path, but distance is not shortest path. That's why it will be always greater than displacement. Hope this point is clear. Now coming to the next question. What is, okay, next, let us say next foundation question. What is the displacement for a round trip? First of all, what is a round trip? So when I'm calling a round trip, okay, just this round trip. Round trip means I'm starting from my home, I'm going to some certain destination, say some Tirupati or some place, and from that destination again I'm coming back here. So wherever I start, okay, after routing certain places, if I come back to the same place, that is called a round trip. For example, I'm starting from here, I'm going to some place, okay, again I'm coming back. So if my source and destination, the source is here only, destination is here only. Okay, don't think destination is some other place. No, I'm not stopping there. Again, I have to come back to my home. So if the source and destination, if they are same, then it is called as a round trip. We say the object has covered an entire round trip. So since the source and destination are same, the initial and final points are same, the displacement will be zero. So in a round trip, remember, since this itself is the initial point and this itself is the final point, okay, the displacement in a round trip, remember this, displacement will be always zero. Why it will be zero? Because displacement needs only 2 points, source, destination. If I join both source and destination with a straight line, that is called as displacement. Now here, initial point is that, final point is that, there is nothing to join. So displacement will be simply zero. Now what about the distance? I have covered a lot of distance here. I have moved, okay, so many places and again came back to the same place. So I have covered a lot of distance, okay. So distance will never be equal to zero. Very, very important. So remember, in a round trip, displacement will be zero and distance will not be equal to zero. Okay, hope this is clear. Now, coming to the next question, third question. Can a curve move downwards in distance versus time graph? Okay, it's a very simple concept. Okay, JEE concept. See, when I'm calling curve, the curves I'll be drawing in 2D only, not 3D. So 2D only. So the in the 2D or Cartesian plane, this line, the horizontal line is called as x-axis, and the vertical line is called as y-axis. Hope you know these concepts. Now, curve moves downwards. Now, can a curve move downwards in distance versus time graph? Now, this x-axis I will take it as a time axis, and the y-axis I will take it as a distance axis. Now, I am starting from origin. Now, understand this concept. It's a very simple concept. Okay, a foundation. I am starting at origin, let us say, and I am moving with respect to time. Okay, with respect to time, I am moving. Okay, time is passing. Okay, 1 hour, 2 hour, 3 hour, so on, 4 hour, so on. Time is passing continuously, and I am continuously moving. Okay, I am moving from my home to my village. If I'm moving from my home to my village, what happens is I'm continuously putting steps forward, and I'll count every step. That I'll be calling distance. So as I'm moving from my home to village, what happens is I'm counting every distance. So the distance will be always positive. It can never be negative. So remember this. So the curve always moves upwards. There is no question that it will come downwards. If the curve is coming downwards, okay, that is meaningless. So remember, distance time graphs, remember, the curves will be always moving upwards. So the curve cannot move downwards. It's impossible. Why? Because earlier we told that distance is always greater than or equal to 0. Distance can't be negative. Hope this point. So in the distance time graphs, remember, the curve cannot be downwards. If the curve is downwards, so this particular concept, will fail. Distance can never be negative. Distance keeps on getting added. Remember this thing. Okay, however you move, wherever you move, every step you have to count. So distance will be always positive and will be additive. So the curve cannot move downwards. The curve has to move upwards. Okay, hope this is clear. So remember, any distance curve, it continuously keeps moving upwards only. There is no question that the curve has to move downwards. So this is clear. In case, in some IIT-JEE questions, if you just see the curves moving like this, the curve is going upwards and again coming downwards like this. So remember, there is a wrong curve. In the distance time graphs, if the curve is moving downwards, the graph itself is wrong. Very, very important point this is. This is a correct graph. The distance curve should keep on moving upwards, not downwards. At any point, it should not move downwards. Now, fourth question. If displacement is 0, then what is direction? Just now I told you that. If displacement is 0, the direction is indeterminate. Direction is indeterminate. Now, fine. Let's do one small question here. After that, I'll stop. Now, foundation question. A student starts from point A. A student is starting from point A. I'll just draw this figure. And performs the following motion. The student is starting from A. He walks 20 meters east. First, what I'll do is I'll just define the directions. The rightward direction I'll call as east. The upward direction I'll call as a north. And the leftwards I'll call it as a west. Downwards south. So they're the directions. Now, from A, he walks 20 meters east. So this is the east direction. So he'll move rightward. So this 20 meters he has covered. Let us say he has moved to some point B. Now then 15 meters west. So if he is moving west in west direction, 15 meters, again he is coming back. So 20 meters he has moved. Total 20 meters he has moved here. Now then 15 meters again west. So he has stopped here. Again he has moved 15 meters. Somewhere here. So from here to here, it is 15 meters. Now the person is at point C. Now then 10 meters again east. Again he is moving east. From here again he is moving east. I'll just highlight with a different color. From here again he is moving eastwards. 10 meters. Okay, 10 meters here somewhere. So this 10 meters. This point I'll call as a point D. So now the person is at exactly at point D. Now finally 5 meters west he is moving. Again he is moving west 5 meters. From D, okay, he is moving west. I'll use some other color. 5 meters here. Now finally he is at okay E. So this is my initial point. Wherever he is trying this initial point, ultimately he stopped at point E. So the point E is nothing but final point. The E point is final point. Okay. Now find the total distance traveled. Be very careful. Find the total distance traveled. This is a foundation question. Now what is the total distance traveled by this person? The total distance traveled by this person is, see very clearly, just keep on adding whatever the path he has covered. In whichever the path he has moved, just okay, keep on adding. From A to B he has moved, first thing. That AB distance is nothing but 20. Now from B he has moved to C. So that is BC. Okay, B to C, he has covered some 15 meters. 15 meters, units are important, don't forget. And from C, he started moving to D, so CD. So C to D, there is 10 meters, you can clearly see this, 10 meters. Now from D, he has finally arrived at his destination E. So D, E, and he has moved some 5 meters, I think. Yeah, 5 meters he has moved, you can just see this. Now add all these distances, finish. Okay, 20, 30, 40, 50, so 50 meters. So total distance is nothing but 50 meters he has covered. This is a distance he has covered. Now, next question is, find the net displacement, that is magnitude and direction also. So let us find out this. Find the net displacement. Remember, displacement depends only on the initial and final position. So initial is this, final we know. So from here, A to B, A to E, I am drawing a straight line. Okay, I'll just draw separately. This A point and say this is E point. From A to E, I am just joining. Now if you see very carefully, from A to E, now see here, A to B total is at 20 meters. Now C to D it is, ED is 5 meters, these are 5 meters, and from here to here it is 5 meters. So it is 5 plus 5. Okay, so it is a 10 meters. Okay, simple calculation. From A to C it is 5 meters. From A to C it is 5 meters, and from C to D it is 10 meters, and from D to B it is 5 meters. So 10 plus 5 plus 5, 20 meters total. So from A to E it is 10 meters. Okay, hope this is clear. Now, so displacement, the displacement magnitude is 10 meters. Capital D is 10 meters. Now he is asking the magnitude and direction. Direction will be what? Okay, from A to E, he has moved rightwards. So the net displacement is from A to E, he has moved rightwards. Okay, that is, you can call direction as eastwards. You can simply write like this, east. That's it. So D equal to 10 meters. There is a magnitude, and east is nothing but direction. Okay, east to west and north to south, you can call them as directions because they will move in one particular directions. Okay, hope this is clear. Oh, fine. In the next concept, we will cover the concepts of speed and velocity and also acceleration. Okay, hope you enjoyed, students.